Hi guys, you are welcome to my channel. In our previous exercise where I displayed this distribution board arrangement, I made a promise that I'll show you how to do your load balancing with your inverter system. Okay, all right. Ideally, after the installation of your building, we have a load balance schedule in our distribution board, which every circuit distributed equally. Then each point that is dedicated to a circuit, for instance, circuit 1 supply, my lighting circuit 1 supply living room as that is sitting room, dining, and the kitchen, and possibly the corridor or the closet or something. So if we want to do the load balance from the distribution board, at the back of the cover of the distribution board, there's what we call circuit description. We are going to describe the direction, the compartment and the apartment where those circuits supply to by listing them, like I just mentioned. After that, you come to the description table and write them down. Now, after that, nobody is authorized to come and change the circuit arrangement and reshuffle the circuit by changing them. If you do that, then during troubleshooting, if you now come, the point where someone now describe where the circuit supply to will be changed. Like if I said a living room and kitchen and one other apartment, then this is where the areas the circuit supply to, and someone now come to install inverter system and change that arrangement. During the troubleshooting, if you find you take it time to locate which distributor, which area a particular point get distributed. So because of that, whatever alteration you are carrying out on distribution board, it shouldn't change the arrangement of the load balancing. You should find a way to integrate your inverter or your solar system without changing the arrangement of your distribution board. All right. So I want to show you how to do that while the arrangement of the DB remain intact. So this is how you do that. Okay, because we do home automation. So because the way we do our home automation, we don't also alter the arrangement of the existing installation of the distribution board. We just come and do our home automation by integrating our system on distribution board. The way the arrangement remain the same. So I will show you that same concept. That is the system and the process you need to adapt while doing your inverter installation at home. So see what I did. First of all, let me show you how this relay function. Okay, let me just quickly bring a neutral and put here. Pay attention, please. And this is my life supply. Let me just send power to this relay. Just monitor how this relay function. I send power to the coil. I send neutral to the coil again. Watch the movement of this contact. All right. Okay, let me simulate. Watch how the contact move from 12 to 13. You see, this is the common. Common is 11. So when I energize, this contact will swap their change. Let me off again. You see this one? Let me off. Okay, you see this terminal return to the original state. All right, so that is what I want to show you concerning a relay function, because we are using relay to do the configuration on distribution board. All right, so all you need to do without altering the default setting of the DB is to invite the services of a relay. Look at my relay. Then look at their coils, their contact. Take away this. So I use that one to illustrate how relay functions. All right. So this is the coil of the relay. These are their contact. Locate the contact and use them to install inside your distribution board. Now the common of the contact is where the load will continue to go out. This one go out, this one go out. I use this load to illustrate the original load that is feeding. Now this is outgoing, outgoing, outgoing. Then you interface a relay to the outgoing. Okay, the common of these relays will remain to the load, outgoing load, outgoing load, outgoing load. You see them light up here now. Then the terminal 14 and terminal 12. 12 is normally closed. 12 is normally closed here. 12 is normally closed there. So maintain the outgoing circuit, put it on normally closed, and take common to your load continuous. Here too, take the outgoing to close circuit and take the load, take the common down to your load. Do that to all the relays you want to electrify. Now this is my circuit. Maybe perhaps I need this lighting circuit to incorporate my inverter. I need this one also to put on inverter. I need this one also to put on inverter. How many all your lighting points here that you want to electrify by inverter, just pass them from the relay contact, interface them with the relay contact. If you also need a particular AC to be fed by inverter, you want inverter to feed any of the power circuit, interface with a relay, look for a relay contact and put it to, then these are the coil of the relay. So this is my inverter supply. So the inverter supply, you take the supply of the inverter, go to the relays and feed them on parallel base, on parallel method, feed them up. This one is just for illustration. The three of them, one, two, three, will come parallel to your inverter supply while they enter the relay. All right. Then you feed the relay to the coil. Whenever the feed the inverter to the coil of the relay. Whenever inverter comes active, these relays will be energized. Once they energize, the contact here will change. We change from the original setting of dB to your inverter supply. Then the load will remain the same. Let's do that now quickly. Now, let me use this one to bring inverter available. You see this inverter flow to the relay and the coil will change. So look at it. I put it on. I energize the coil of the relays I use to interface on DB. Then the coil will close and change. Change to my inverter. Look at my inverter supply. Inverter supply this one, this one, this one. Then once it closes, I have my load. This is a continuous load taken from inverter. This one to taken from inverter. This one to taken from inverter. If I shut down inverter, you see them coming back to DB original line they are. Let me shut down inverter. Now see them coming down to original setting of the DB. So this is the ideal way to do your inverter incorporation so that the three-phase distribution or the genset, remember that some of the client uses three-phase generator. So that load balancing of the three-phase winding from the alternator must be maintained, because if you make your alteration here by changing, taking one of the phase to put on lighting circuit, then taking the whole of the load on that phase to share to this other two phase. One phase, this phase that is lighting, that is controlling lighting circuit, we have lesser load. While this other two phase, we take higher load, thereby sending imbalance voltage and current carrying capacity to the distribution board, to the genset. And the winding of that genset, the lifespan will be at stake because the load is no longer balanced. So to maintain the balancing of this distribution board, this is what you need to do. Interface your DB with a relay. So relay changes to your inverter and changes to the original setting of the DB. So this is the formal way and the professional method of doing your inverter installation by incorporating your inverter system into the existing installation setup of the distribution board. All right. So I give you this idea because during our automation installation, we will go to home automation. This is what we face. So when we come, we incorporate our own home automation without altering the arrangement of the distribution board by integrating our system alongside with the distribution board. All right. Okay. So thank you. Follow me for more update like this. Like I promised, I'm going to give you electrical update, professional electrical skill. I want to download them to your head. So make sure you copy and you share to your fellow loved ones, especially students. If you have any of your friend or your relative that is in school studying electrical engineering, make sure you share to him. Thank you.